Alright, let's try another problem from chapter 14. A straight segment of wire has a length of 10 centimeters and carries a current of 5 amps. It is oriented at right angles to a magnetic field of 0.6 Tesla. What is the magnitude of the magnetic force on this segment of wire? Okay, so this one's a little bit more abstract. You have your wire here. Let me draw it in a different color here. Draw like this. Maybe you can see this. Okay, here's our wire. It's 10 centimeters. That's the part we're looking at. And then you have this magnetic field coming in. What is the magnitude of the force on this segment of wire? So what force are we going to feel? Well, let's look at that. So let's write out everything we know. We know the magnetic field is 0.6 Tesla, and this is a little abstract. Hopefully you've read the notes on this section. The current is 5 amps, so there is a current going through here this way. The length, it's 10 centimeters. Let's make that meters. Okay, and we're looking for the force. There's the magnitude, magnetic force, so I'll put an M for magnetic force, F of M. Okay, well, there is an equation that deals with all these variables. It's the magnetic force will equal your current times the length of the wire. It's 10 centimeters this way. Times the magnetic field, which is B. Oh. Right, so we have 3 of the 4 variables. We're in meters, so we're good to go. If you take a Tesla times an amp times a meter, the units do cancel out to where it's a, you know what unit it is? Hopefully you know it's a Newton. So your answer should be in newtons because we're dealing with force. If you take a Tesla times an ampere times a meter, you will get a Newton. Okay, let's try and do another problem. And if you want to know about that, ask me. I'm not going to do it right now. Suppose that water waves coming into a dock have a velocity of 1.2 meters per second and a wavelength of 2.4 meters. With what frequency do these waves meet the dock? Well, the speed of a wave, so I'm going to use, well, it's velocity. I need to use V. It was going to get tricky. The speed is 1.2 meters per second. The wavelength, I'm going to use that guy to say wavelength, 2.4 meters. And the frequency, I'll do it in a fancy F this time for frequency. Your book might use something different. I'm going to use fancy F. We don't know about that. We're in meters per second here, so the equation of the velocity of a wave is equal to the wavelength times the frequency. Hey, we got 2 of the 3 unknowns. We just need to rearrange this equation to solve for the frequency. So we're going to divide by wavelength on both sides. So we have the velocity divided by the wavelength will equal the frequency. And if you're like, well, what unit is that? What unit does frequency have? It's not time. Frequency is different than time. Well, let's take a meter per second and divide by wavelength is meters. So a meter divided by a meter, that goes away. Now we have 1 over S, so that equals 1 over S. That's the unit you need. You need to have some number with 1 over S as the unit. So take 1.2 divided by 2.4, and frequency is 1 over S. That's the unit. Alright, we're done with that one.